If you have ever looked up at the night sky and wondered how stars are born, why galaxies shine, or what drives the universe itself, this video is for you. Today I am talking about one of the most complete and self-contained books in astrophysics. A book that takes you from the basics of astronomy to the physics behind the cosmos. It is clear, comprehensive, and designed to make even the toughest concepts feel accessible. Let us explore the book that truly brings the universe to your fingertips. My name is Shaunak and you're watching this video on my channel, Physics for Students. Well, before I go ahead and explain about this magical book, let us understand what actually is astrophysics in a very simple language. Well, the definition talks that it employs the methods and principles of physics and chemistry in order to understand the astronomical objects and phenomena. Well, to take it in further easy language, I would say that it takes the familiar equations of motion, thermodynamics, electromagnetism, and quantum mechanics and relativity, and it applies to the most extreme laboratories in existence, stars, galaxies, and black holes. In short, we can tell it is physics turns outside, looking at the universe itself as a grand experiment. But remember, astrophysics does not invent the new physics of the universe. What it uses is the laws that describe, for example, this bouncing ball, Newton's laws of motion. This one, which is showing how heat flows, thermodynamics, how light behaves, electromagnetism, and the smallest particles, how they work, the quantum mechanics, and how space and time itself bends and curves, the principles of relativity, all still apply out there among the stars. So we can say, in essence, the universe is a physics classroom on a cosmic scale. Now, having said that, the next thing that comes to our mind is, what is astronomy? Well, astronomy is asking, well, what is out there in the universe? Astrophysics asks, how does it work? That means astrophysics is less about cataloging. It is more about comprehending, using the laws of physics to find out what actually exists there. So what we can say is that every twinkling star, every faint galaxy, every mysterious burst of radiation is a physical system, and that is governed by the same universal laws that act on Earth. So astrophysics basically asks questions like, how does stars generate light and heat? Is a star's lifespan determined? Do galaxies form structures over billions of years? And is the universe expanding, and what might be its ultimate fate? So from here we can say that it actually reminds us that humans are a small part of this vast cosmic story, yet capable of understanding it through the pure reasoning and mathematics that we are going to see now. So what is actually the distinction or the relation between astronomy and astrophysics? Well, you can say that astronomy is basically studying the celestial objects. It is the scientific study of celestial objects such as stars, planets, comets, and it is more based on observation. So it includes observation and theoretical aspects, focusing on position, where it lies, etc. And it very much uses telescope because it is more about gathering data on the position, luminosity, motion, and composition. And an astronomer is a person who actually use powerful tools like telescope, ground-based, etc., and collect those data using those instruments and the celestial object. This is all we can say about astronomy, which is more about gathering and cataloging the data using telescope and other powerful instruments. Astrophysics, on the other hand, is more applying the principles of physics, which we just saw, quantum mechanics, relativity, etc., and uses physics to understand gravity, nuclear fusion, and so on. So who is an astrophysicist? Is a person or a special type of physicist who studies the basic workings of the universe using the laws of physics, understanding stars and planets. So it more or less explains why and what is the reason behind this astronomical observations. So if I take a kind of a tabular structure to make you understand what is astronomy and astrophysics. The scope is astronomy is more on observation and study. Astrophysics scope is more on using the principles of physics and to understand why these celestial objects behave in this way. The method is mostly using telescopes. Here it applies methods of quantum mechanics, principles of relativity, kinematics, etc. Approach is more both observation and theoretical. Here it is more focused on using the theoretical model to understand what is the reason that this celestial phenomena happens. So overall what we can say is that there is a significant overlap, and that is why students get confused between astronomy and astrophysics. So the emphasis is basically astronomy on observation and description, and astrophysics using the theoretical and physical principles. Having said that, I would also like to tell you in a quick what are the different branches of astrophysics, because I have seen a lot of young students and scholars, they venture towards this. So one branch is basically called stellar astrophysics, which basically studies what are called why the stars are born, even die, their process, etc. There is something which is called galactic astrophysics, which examines galactic structures, the shapes, evolution, etc. And there is another part which is very common, which is called cosmology, exploring the original, the fate of the universe, and so on. High energy astrophysics also investigates extreme phenomena like black hole, supernova explosion, red giant, supergiant, and so on. Planetary science explores the different planets, exoplanets, their physical formation, etc. And astrochemistry studies how chemical elements and molecules, they are born and they interact, etc. So these are basically the different branches of astrophysics, and there are many also. Now, what is the best book? The central part, that what is the best books to start learning astrophysics? And here I would be talking about this book. It is basically written by Bradley W. Carroll and Dale A. Ostile, and it is also considered to be an astrophysicist Bible. Now, why it is Bible? Because it is quite heavy. Now, you can see here the product description. I have mentioned that it contains around 1300 plus pages. So that is why it is called a Bible, because you will see why it is called a Bible. These are the two famous authors who have written that, and the Amazon rating is more than 80%. The total weight of the book is around 2 kilograms. That is something a little bit heavier compared to other books, and as you can see, the number of pages are quite extensive. Now, the book is being arranged in this way. What is the arrangement of the book? First part contains the tools of astronomy. As I told, that astrophysics is more about using the rules of astrophysics or the rules of physics. So first you need to understand astronomy, that is the observation part. I will go in these details a little bit more. This is how the book is arranged, and I can say that this is the way that every astrophysicist student should take up the learning. First, learn the tools of astronomy, then the stars formation, sun, stellar pulsation, general relativity, black holes, stellar atmospheres, etc. Then the book actually speaks of solar system, the different terrestrial planets, realms of the giant planets, galaxies, and the universe comes next. Milky Way, nature of galaxies, galactic evolution. So this actually covers what is called the arrangement of the book. So you can go again. It will start with the stools and then the nature of stars and further on. Now, if I go for the table of contents, you will see why it is called a Bible, because it covers everything. Not almost, I would say everything. So you can see it starts with tools of astronomy, very intensive and extensive both. It starts with celestial spheres, celestial mechanics, continuous spectrum, and then gives quite a good review of special relativity. Then it goes in interaction of light and matter, telescopes, etc. So this is the basic content. Then comes the sun, the interstellar, the stellar pulsation, fate of massive stars. So part 1 up till 170 pages are basically building you the basics. Then comes the nature of stars. If I go further, you will see it contains next what is called the solar system, the physics, the process, and then it turns into what is called the galaxies of the universe, galactic evolution, and concludes with cosmology. These are basically the solar system data and the images and the appendix and suggested reading. So that is why you can see it is already 1230 pages of pure content, and it covers everything starting from astronomy to astrophysics. So what is the key takeaway from the table of contents? So what you can understand is that you will first learn the foundational concept, physics and mathematics behind it, relativity, telescopes, etc., the arrangement. Then you will learn the nature of stars. And not only about this book, I would strongly recommend you, if you're a beginner on astrophysics, you should follow this path. This is the best path, and this is a path which will clear everything step by step, and you won't be confused by the plethora of astrophysics, the physics that we deal in. So here you can see it focuses on stellar properties, examines stellar interiors, etc. After the natures of stars, then it looks into the suns, planets, planetary formation, etc. Further, it goes in what are called galaxies of the universe, where it covers up the structure and the evolution, cosmology, expansion of the universe, and then it gives you the overall key insight. That means the book progresses logically from tools, stars, system, galaxies, universe, and then it blends mathematics and observation into a cohesive understanding. So everything taken together, what is the mathematical prerequisites? That means what you need to know about this book. You should know obviously calculus, single and multivariable, differential equations required at any part of your time, linear algebra, probability and statistics, vector and tensor, and complex numbers. Finally, the Fourier series, which I don't consider to be mandatory. If you learn, it will be great. So overall, I would say the book already assumes a very good understanding at a university level of mathematics, because the book won't teach you the maths right from the beginning, but it assumes that you should know this level of mathematics. So here is now a quick review of the book. If I talk of the strengths, it is exceptional because it goes length and breadth. It covers everything about astrophysics, mathematically rigorous. The details, derivation and other things are there. It is very logical, so you won't find any problem in going ahead with that. And pedagogically, it is very strong because a lot of examples and figures and end of chapter of varying difficulty it is being given. And it is very comprehensive. At the end, you will see a lot of reference material, books, websites, which you can go ahead and read. So strengths are amazing. It is very logical and easy to understand. If I talk of the weaknesses, then it is very heavily mathematical. You need to know the mathematics, density of the content. Each chapter is information rich. So it is not a very easy textbook to go about. However, there are limited focus on certain recent discoveries, and the conceptual summaries are very sparse because derivations are given, but conceptual key takeaway or summarizing the concepts are not very well given. However, you can ignore all the weaknesses and consider this to be the best book to start learning astrophysics for beginners. That's all for today's video. Thank you very much. If you have taken up time to watch this video, please do not forget to subscribe to my channel Physics for Students and keep the bell icon ringing so that you get all the notification from Physics for Students. You can follow me on my social media channel, which I am very active, and I'm putting up a lot of interesting things apart from physics and mathematics, and you can write to me on this channel. Coming up with very interesting and a very serious podcast in a few days time from now. Stay tuned for the announcements and other information from Physics for Students. See you soon in the next video, but till then, goodbye, and may the good Lord be with you.